doing translations, when moving a figure from one place to another, we usually have a formula. Our example formula is xy translates to x plus 3, y minus 6. And our triangle is starting out with A at the location 2, 4, B at 4, 1, and C at 2, 1. To move the figure to the formula, you have to take each individual x value and plug it into the equation, and do the same with y values. For A, you will get 2, 4 changes to 2 plus 3, 4 minus 6. You solve the second set of parentheses, and then plot that coordinate on the board. Do the same for the other points. The triangle's new coordinates are A1 is at 4, negative 2, B1 is at 7, negative 5, and C is at 5, negative 5.
Explaining reflections. When reflecting a figure across a line, it is very important to have each point be the same distance from the line. Here, we will be reflecting this square over the y-axis. The point A is 3 units left of the line, so point A prime needs to be 3 units right of the line. Point B is 1 unit left of the y-axis, so point B prime needs to be 1 unit right of the line. The same goes for points C and D. The reflected square is at B prime 1, 3, A prime 3, 3, D prime 1, 1, and C prime 3, 1.
Dilations. A dilation is an enlargement of a figure on a coordinate plane. For example, if you wanted to see what a figure on a coordinate plane would look like if it were doubled, then you would multiply all of the coordinates of the figure by 2. A figure with coordinates 1, 3, 3, 3, and 1, 6 will be used for this example. If you wanted to double these figures' size, you would multiply each coordinate by 2. All the coordinates will become 2, 6, 6, 6, and 2, 12.
Rotations. A rotation is the process of a figure turning around a fixed point. To rotate a figure, you need to turn the paper the desired angle and take down the coordinates of the figure. For example, this figure we're going to turn 90 degrees clockwise. We're going to take down the coordinates of all of these figures, of all of these letters, and then we are going to flip the paper to the original position, and we are going to plot them. And as you see right here, this is what the figure looks like after the transformation has been done.
Transformations are constantly used in the field of animation. Animators use translation to move their characters around in a scene. They also use reflection to create a symmetrical being, such as dragons, shown here. Now rotation is being used as the dragon turns to dive down.
Question 1 is going to be a dilation. We're going to dilate this figure by a scale factor of 2. Please pause the video. As you can see, the coordinates are 4, 2, 9, 2, and 4, 7. As you can see, the figure has been dilated. The new coordinates of the figure are 8 prime, 8, 4, B prime, 18, 4, and C prime, 8, 14. Question 2. We're going to reflect this figure across the y-axis. The starting points are A, negative 5, 5, B, negative 2, 5, C, negative 2, 2, and D, negative 5, 2. Here is the answer. The new coordinates are A prime 5, 5, B prime 2, 5, C prime 2, 2, and D prime 5, 2.
Question 3. Rotate 90 degrees clockwise. Coordinate for L is 1, 4. Coordinate M is 3, 1, and coordinate N is 1, 1. Please pause the video here, ma'am. This is our new figure. L prime equals 4, negative 1, M prime equals 1, negative 3, and N prime equals 1, negative 1.
Question 4. Translate the square 5 units to the right and 7 units down. Coordinates A are 1, 8, coordinates B are 4, 8, C is 1, 5, and D is 4, 5.
Please pause the video here.
The answer is shown there. A prime equals 6, 1, B prime equals 9, 1, C prime equals 6, negative 2, and D prime equals 9, negative 2.
Question 5, we're going to reflect the rectangle across the x-axis. Coordinates of Q are -3, 5, R -1, 5, S -3, 1, and T -1, 1. Please pause the video now. The answer to this question is Q prime -3, 5, R prime -1, -5, S prime -1, -3, -1, and T prime -1, -1.